Blox is a leader in prefabrication. They started prefabricating hospital bathrooms that leave the factory with all their plumbing and electrical systems already in place. Now they've moved on to prefabricating complete trauma centers and labs. They're working on a 175-bed hospital in Reno, Nevada that will be 90% prefabricated. And this enables them to build a facility in a location without enough labor to meet the demands of traditional processes. Chris Giatina is here to share his work. Please welcome Chris to the stage. Thank you.
Filippo Brunelleschi is the archetype of the master builder. He was a possessor of a vision and creativity, of engineering and material ingenuity. He was able to get people to do things that they didn't want to do, and he was able to navigate a political minefield and the political strategies that would allow him to stay focused and to do what he was there to do. So it's interesting that this, without him, without a master builder, for 140 years looked like this. And it was Brunelleschi who saw what others couldn't see and possessed the technical chops to make it real. And so why in the world did we replace Filippo with siloed experts focused on compartmentalizing risk? You might ask, there's some subtext to that. But I'll submit to you that this is not true, but I love to think of it this way. This is the École des Beaux-Arts in the 1800s. 150 years after Louis XIV establishes the school, the transition of the architect as a master builder to the gentleman is almost complete. You can see the top hats and capes have replaced Filippo's leather apron. And so this is my dad. And we're standing at a project site looking at something that we're making. My dad is a master architect. He's a master builder. He's really the only one I've ever known. He was an anachronism in his own time because he fought as NCARB president and others to keep the architect whole at a time when the profession was moving away from it. His granddad came from Sicily to be a stonemason. He found himself a bricklayer in Sloss Furnace. Sloss Furnace is where they made steel in Birmingham, Alabama. His dad was also a mason. He grew up making things, and it was impossible for him to divorce the notion of creating something from how it was made. So as a kid at the kitchen table, he taught me the value of being a generalist. And the generalist, he believed, was the only one with the skills and the knowledge to see something whole from the conception of the idea through to its physical realization. And so that influenced me significantly. I'm part of architecture, engineering, and construction. I'm a second-generation architect, and I found myself part of an organization, part of an industry that wanted me to think a certain way. And so in 2008, some of you are old enough to remember that. It was not a great year, and that liberated us to think about what we wanted to do instead of what we had to do, or what our profession was telling us to do. So we took architecture, engineering, and construction, and we overlaid it with another structure called design, manufacture, construct. And it says it replaces nouns, architecture, with verbs, design. It adds manufacturing to the mix because we knew intuitively, even if we didn't yet have the skills to make it real, that manufacturing was going to be a tool, a component that would enable us to make things. And finally, it was a system that we knew was a singularity. It wasn't design, then manufacture, then construct. It was to think holistically about that as one. And so DMC's aim is to teach a legion of designers how to leverage manufacturing productivity, which we have to invent, as a group, as an industry, so that we can simplify construction, which is what we need. We measure its success on this equation, 2 by 2 by 2. It has to be twice as good. Everything that we touch, we look at, is it twice as good as the alternative? I'm not suggesting that we always get there. I'm suggesting that that is our aim. Does it have half the footprint of carbon? Does it have twice the energy efficiency? Does it improve human productivity by 2? Then does it happen twice as fast, measured objectively from the mobilization on site to the certificate of occupancy, right? So a concrete measure we'll look at. And then finally, does it inure to be twice the value to the user, to the owner, to the community? If we can do those things, we felt we would be relevant. But to do them was really challenging within the existing paradigm, and some of you know this. It starts with an idea. And the existing paradigm moves that we have an idea, and then we go to design, and we go from design to model, and from model to construction documents, and from constructions to general contractors who parse that out into risk management tools, to subcontractors who submit proposals, who go back to the GC, who goes back to the architects, which we may or may not want to hear about. Ultimately, way down here, we use it. Someone gets beneficial use out of it. And this conference is focused in large part about shortening the spaces between idea and design, between design and model, between model and construction documents, between submittal. And that's not a bad thing, but that won't get to 2 by 2 by 2 because 2 by 2 by 2 is an 800% delta. If you pick up all of the spaces between these, you may pick up a 5% charitably. To get to an 800% delta, you have to systemically rethink the entire concept. And so what we're doing is we're going from model and we're going for fabrication, like many people. But we're doing it systematically, and we're doing it at a program level, and we're not working on shortening the gaps between them. We're working on removing them. And of course, that requires some technology. And so we've developed a platform called Weaver. It is a pretty broad tool that uses our own software development with Forge and BIM 360 and other pieces. It takes manufacturing's raw materials. It takes constraints from design. It puts those on the cloud. It creates a digital catalog. The digital catalog is then available to people. And this is what a lot of people are doing. And what's interesting about this is design separated from the means and methods. And so what we want to do is connect that to factories. And so Blox has a factory, it's 1 million square feet in Birmingham, Alabama, and we make stuff. And we find other people that want to make things. And together we're creating a series of standard parts and custom parts that go together that fill back to the cloud, and they can be deployed on a digital catalog that's ever increasing in size, and they can go to our internal customers and to our external customers. And so this thing operates, DMC, as a continuum. It's not a singularity, it's a continuum. And it begins with the idea that we talked about, the design and the model, and then it moves to the raw material for whatever that project may be or whatever that program, and it looks at tools that can convert that raw material, sheet, roll, coil, into parts that operators can assemble, not tradespeople. Those parts can be assembled by operators into increasingly complex subassemblies, into increasingly complex panels. Panels can be made into modules. Modules can be made into Uber modules. Uber modules can aggregate and turn into buildings. This is our continuum. It's what we're working on. We're working at the spaces between these to create the intelligence that makes this easier and easier, but it's not a straight line process. We're not a volumetric builder, though we do volumetric. We're not a panelizer, though we do panelizing. We sometimes move raw materials to sub-assemblies, and sometimes we take parts and bring them straight to one of our job sites, and sometimes we move at any place between. We're looking for an optimal path based on the exigencies of the site. We apply those to a manufacturing process which is built around a Boeing's 787 Dreamliner method, which is called chunking. It's a beautiful idea, super simple. It's a little different than mass or lean. It takes massive chunks. It builds 22 parts in 9 countries. This is made in Japan. It's complete. It'll have seats and hydraulics all the way to a paint job. It'll attach to something that's made in the US and something that's made in Italy. It'll be put together in Boeing's plant in Charleston. And this is what a construction site of our future will look like, in my opinion. It will look like a place where we assemble large chunks. This is our chunk. It's an Uber module. It's 15 feet wide, 15 tall, 60 feet long. It gets its name because it is the largest that the DOT will allow us to ship. This is where we make it in a plant. We have multiple lines. We have multiple buildings. There's a 1 million square foot facility. This is an Uber being installed. It can have varying levels of complexity. This is one that's open. It creates open, well-lit spaces that are gorgeous. This is a building information model of a whole building. This happens to be a clinic, a freestanding emergency room. The red is a Uber of many Ubers that are in there. When you pluck it out, it's made of smaller components. This is an MEP rack. The MEP rack is made up of MEP panels, which can be extracted. The MEP panels are extracted into subassemblies, which are made from bombs, which are parts. All of these things work together as Russian nested dolls in a system to make really complex things really smartly. This is our application called Stitcher. Its goal is to take technology and put it in the hands of our operators who literally stitch a building information model using a Forge platform, but a Stitcher overlay, to create module-specific bills of materials that connect to our financial system and our inventory system. We also take those pieces and move them from the building information world to a G-code world. So really, once you have a level 400 plus model, the next step is to turn it into G-code, which speaks to machines. We've used various machines, some of them really dumb machines because we haven't been overcapitalized, I think is what our banker said. The idea was we took MDF and we created fixed jigs that could be made panel by panel until we were able to develop cold rolling pieces to replace those, until we were able to then add additive to develop jigs and fixture components, or subtractive material, which would use laser and plasma to make sheet goods into particular parts, all which could be assembled into modules. The modules can be erected with a great deal of complexity. Keep in mind that everything in this picture is something that we may have made from a kit of parts. We're just highlighting the module here. It could have been an OR room. It could be an entire patient room, which we're doing around the corner in Henderson right now. So these pieces are important. All of these modules accrete to a master kit of parts that begins to inform the built world. I can add parts to it, and once I've built it digitally and I have the tools to manufacture it, I can reproduce it in quantity. Once I can get quantity, I can begin to affect markets. So this is our Weaver digital catalog. It is used to make a flat pack steel. The flat pack steel can be 1-story, 2-story, 3-story. It's a kit of parts. It could be made into a U or a L or a Z. It is added with modules, exterior skin, MEP, functional modules inside, to make world-class architecture that is operationally efficient and that's beautiful and site-specific. And so, as this plays, I'd just like to close. A handful of the world's largest companies are using Blox to redefine their building programs. We've built a team of insanely smart people, 400 architects, engineers, programmers, manufacturers, contractors, our constructors. And we're all working under one roof in an attempt to solve the very, very hard problems that will allow us to shift the AEC towards a DMC model and to make our industry better. Thank you very much.